Hello, everybody. Today we will be solving problem 4 of the 2019 JMO. The problem reads, let ABC be a triangle with angle ABC obtuse. The AX circle is a circle in the exterior of triangle ABC that is tangent to side BC of the triangle and tangent to the extensions of the other two sides. Let E and F be the feet of the altitudes from B and C to lines AC and AB respectively. Can line EF be tangent to the AX circle? And I've gone and drawn out a diagram with all of the points, and I've gone ahead and added a few things. And in particular, I added the reflection of BC across the angle bisector of this angle, angle A. So if this is the angle bisector, and note that it goes through the X center. There's a lemma about that. We see that B reflects onto B prime on this side, and C reflects to C prime on this side. And what's more is that since BC is tangent to this X circle by definition, then by symmetry, B prime, C prime is going to be tangent to this X circle as well. So I'll get rid of this angle bisector for now. And then we'll take a look at this diagram, and we're going to take a look at it, and then we're going to say, okay, at first glance, B prime, C prime looks parallel to EF, and I'm actually going to go claim that. So claim is that EF is parallel to B prime, C prime. And that is easy to prove. Okay, so what we need to do to prove that EF and B prime, C prime are parallel is prove that these two angles are equal to each other. And then by transversal, we would actually get that since these angles would correspond, then EF and B prime, C prime would be parallel. Okay, so what I'm going to do is I'm going to note that this angle over here and this angle over here are equal to each other just by symmetry and by properties of reflections, right? Since we reflected BC across over here, this angle is going to be equal to this angle since reflections preserve angles. Okay, now I'm going to take a look at these 4 points, C, E, B, F. Okay, and I'm going to claim that this quadrilateral is cyclic. And that's also easy to prove because angle BEC is a right angle, angle BFC is a right angle, so they add up to 180 degrees. Okay, so CEBF is cyclic. Write that down. Okay, and what that means is that angle FEC, that's this one over here, is equal to angle FBC because they both subtend arc CF on the circle, right? So this angle is going to be equal to this angle, but we knew by properties of reflections, as mentioned earlier, the angle FBC, which is angle C prime BC, is going to be equal to angle C prime B prime C, right? So essentially what we have is angle FEC is going to be equal to angle C prime B prime C. So those two angles are equal, so therefore EF is indeed parallel to B prime C prime. Okay. Now I'm going to prove that EF is closer to A than B prime C prime. So first let me mark these. First let me mark these parallel lines. Now I'm going to claim that EF is closer to A than EF is closer to A than B prime C prime. And this is easy to prove. All we have to do is prove that E is closer to A than B prime and F is closer to A than C prime. And then since EF and B prime C prime are parallel to each other, since they go in the same direction, then the entire line EF is closer to A than the entire line B prime C prime. Okay. And what we do is we notice that since reflections would preserve lengths, AB prime is going to be equal to AB. Right? And we also have, by Pythagorean theorem on triangle ABE, that AB squared equals AE squared plus BE squared. Okay, and what this means is that, okay, since we have BE is non-zero, that's trivial, otherwise this entire triangle would be degenerate. Since B is non-zero, we'd have that AB squared is AE squared plus some positive number, which would mean that AB is bigger than AE. And because AB is equal to AB prime, then we also have AB prime is greater than AE. Then by similar logic, we have that F is closer to A than C, which means AF is less than AC. We can prove that in essentially the same way using triangle ACF. And note that AC prime equals to AC, and AC squared equals to AF squared plus CF squared. And since CF is non-zero, otherwise everything's degenerate, we have AC is greater than AF, so AC prime is greater than AF prime. Okay, which means that, sorry, this is AF, not AF prime. This means that E is closer than B prime and F is closer than C prime to A. Right, so EF is closer to A than BC. So this claim is also proven. Sorry. Okay, so and we also know from the very beginning that B prime C prime is tangent to the circle. Right? And this circle is essentially on the other side of B prime C prime, and the circle are essentially on opposite sides, right? But since EF is on the same side as A, EF will never touch this circle because this line touches the circle at one point, and this line and this circle are on opposite sides of this line BC. Right, which means that EF and this circle will actually never intersect, which means that the answer to this question, can EF be tangent to the AX circle, which would mean would EF touch the circle at one point, is the answer is no. Thanks for watching, and I will see you next time.